What are higher order functions? Higher order functions are ones which take a function as an argument or return a function as a result. What are higher order functions used for? They're used for a few things, such as avoiding repetition or DRY. DRY stands for don't repeat yourself. Higher order functions allow you to avoid similar coding patterns being in multiple parts of the code by abstracting them into higher order functions. And I'll explain more about that in a minute. So they can also be used with currying and partial application of functions. The thing is, with currying, right, every curried function is actually a higher order function, because in order for currying to work, it takes, essentially what currying is, right, is it takes a function which has multiple arguments and turns it into a series of functions which each have one argument and one return value. However, in order to do that, all functions except from the last function in this series of functions return a function, and because they return a function, that makes them a higher order function. If you don't know what currying is and you want to go into more detail, I actually have a video on it which I'll be linking in the description. But yeah, essentially in Haskell, functions are curried by default, and higher order functions allow for more readable partial applications of curried functions. And if you want to know about partial applications, again, it's in my currying functions video, which is linked below. Okay, what's the other thing? Well, it's called encapsulating behavior. And for this one, I actually have an example for this apply twice function, right? What apply twice does, right? Basically, you know, it takes a function and it takes an argument, and what it does is it applies that function to that argument twice. So basically it takes this function, right, which in this case this is just for ints. It takes an int and it returns an int, that's the function. It also separately takes another int, and this int here, right, is curried because it first takes this, right, as one argument, then it takes this as another argument, okay, and then finally it returns a integer as a result. And if we have a look at it here, this is the definition. It takes f, which is the function, takes x, which is the value it's taking, the argument, and then it applies f to x. So it does f of x, right, f of x, and then the result it passes into f again. So apply twice basically takes a function and an argument and applies the function to that argument twice. Yeah, so passing different functions, what encapsulating behavior is it's passing different functions to alter the behavior without changing any of the program's logic, right? And you can see that in this example. So apply twice, if you pass it the function times by 2, right? Apply twice of 5 with f being times by 2, yields the result 20, because what it does, right, is it goes 5 times 2, which is 10, and then times 2 again, which is 20. However, by not changing any of the code in the apply twice higher order function, and just passing it a different function, in this case times by 3, it gives you a different result, because the logic is different. So the logic is the same, but the behavior is different because we passed it a different function, right, with this times by 3. Because what it does here is it goes, okay, we're applying times by 3 twice. So you do 5 times 3, which is 15, then times by 3 again is 45. And that's how encapsulating behavior works and how higher order functions works. So this video is actually about using higher order functions. So I will give you 2 higher order functions that you can use. Now, these are going to be map and filter. So first off, map. Let's have a look at the definition of map. First off, let's have a look at the recursive definition. What map does, right, is, because it's a higher order function, right, it takes a function, and it takes a function which maps A to B. Now, if you haven't seen this A to B stuff or this A stuff, essentially what it is A and B can be any data type. This is called parametric polymorphism, or you will often just hear it referred to as polymorphism, because parametric polymorphism is the only type of polymorphism that Haskell uses. But what it means is that this A, as long as this A is the same as this A, and this B is the same as this B, it doesn't matter what the types of A and B are, as long as they're the same. So basically what this function is saying is take it takes a function, right? This is also queried, as you can see, because it first takes the function, then it takes a list of A, and then finally it returns a list of B. Alright, so this is the definition. It takes the function f, and it takes the list of A like this. And what it does is it basically says it has x and then x's. What this does is it separates the function, sorry, not the function, it separates the list of A's into two bits, x, which is the first item in the list, and x's, which is x's is the rest of the list. So basically it just takes the first item off the list. And what it does is it applies f to x, and then it recursively calls map again and applies f to x's. And actually, because this is a recursive function, we have to write the base case, or else it won't work. So you just add this basically, because what will happen, right, is if we didn't have the base case, once it passes an empty list, you know, it will just keep going, which we don't want. So we need to say, if you're passing the empty list, then just return an empty list. I forgot to add that, but that's fine. Essentially, right. And what this colon here, this is the cons operator, which is used for attaching items. In this case, it's prepending whatever this result here is to the new list. And essentially what this will be, if I just show you now, I can do, the result of this will be something like, it will be like 1 cons, say we just have a list 1, 2, 3, 4, right? That's the cons 2, cons 3, cons 4, cons empty list. And what that will result in is 1, 2, 3, 4, right? Because technically we should have brackets, right? You get the idea with brackets. I'm not going to write them out, but you should technically have brackets. And that's how it works, right? Let's have a look at the list comprehension version, because this is more simple, I think. If you don't know what list comprehensions are and how they work, then I will link a video in the description that I will make, haven't made yet, but I should have made soon. And as soon as I've made it, I'll link it in the description of how to do list comprehensions. Anyway, so as you can see, it's got the same type definition for the list comprehension version, because it's still the same function, it's just defined in a different way. Right, with this one, with this map, is it still takes a function and it still takes a list. However, it doesn't do any of the splitting the list up or anything like that. But what it does is it draws x from x's. This is what this bit here, this is the generator part, and then it says for each x apply f to x and then put it in a new list. And that's how it does it. So as you can see, this map function, what it does is it takes a list and it takes a function and it applies that function to every element in the list. Let's have a look at an example. So if we do map +5 and then the list of 1 to 5, if you haven't seen this dot dot notation, essentially what it means is generate a list of items between this number and this number. So it generates the list 1, 2, 3, 4, 5, right? And then +5 will apply the function +5 to all of the functions in the list. So 1 + 5 is 6, 2 + 5 is 7, and so on, right? I hope that's clear. Now let's have a look at filter. Filter is another higher order function that you can use. And then it's got, I'll show you the two definitions. The recursive definition first again. And basically what filter does is it takes a function, right? Because it's higher order, takes a function which maps anything from A to a Boolean, right? And then this is sort of like a condition for, so filter will take a list and a function, and if for each element in the original list, if it satisfies the function and the function returns true, then it will add it to the new list. If the function returns false, then it will exclude it from the new list. Okay, and then so first off, it's also queried, right? Because it takes a function and then it takes its second argument, which is a list of A's, and it will return a list of A's because it doesn't transform any of these values in any way. It just simply selects whether the values go into the output list. Right, so let's have a look. So filter, oh wait, this is actually the list comprehension version. Oh, it looks like I've got them the wrong way around. So this is the list comprehension version, and then this is the recursive version. I hope that didn't confuse you, but you should see it now. So this is the recursive version, and I'll get onto the recursive version in a minute. The list comprehension version, right? So it takes f and it takes a list x's, and it's got another list comprehension, right? So it draws x from x's, right? And it will put x in the new list, but it will only do it based on this guard clause, right? And this guard clause is f of x, and f of x, if f of x is true, then it will put it in x's. So then it will put it in the new generated list. If not, then it won't. Okay, let's have a look at the recursive definition, which admittedly is a bit longer. What this does, again, function type definition is the same. We have a base case this time. We have a base case with every recursive function, right? And what it does is it splits the list for the first item and the rest of the list. What it will do is, if f of x is true, then it will add x to the list and then call filter with f and x's on the rest of the list. Otherwise, which in the standard prelude is defined to be true, as always. This is basically if else. This is known as a guarded expression. I will be making a video on guarded expressions as well. That will be linked in the description as soon as I've made it. Otherwise, basically, like if f of x is false, then it will still call the rest, but it won't add it to the list, which is how it can exclude it. And hopefully that makes sense, because the filter basically just filters the things which don't match the condition. And then let's have a look at an example. So with this, right, you pass it a function. This function is actually an anonymous function or a lambda function, right? What it does is it takes a value x and it says if x mod 3 equals 0. So the return is if x mod 3 is 0, i.e. it checks if it's divisible by 3. So if the number is 3, then it returns 1, or it returns true, right? And if the number is like 4 or something, which isn't divisible by 3, it will return false. And then we also pass it a list. In this case, I passed it all the numbers between 1 and 15. And then what filter will do is it will return all the numbers which are divisible by 3, which in this case is 3, 6, 9, 12, and 15. Okay, thank you very much for watching. If this was useful, like and subscribe and all that. I've mentioned a few videos which will be linked in the description if you want to have a closer look at some of the things that I've mentioned in this video. And of course, yeah, thank you very much for watching. More videos will come.